Welcome. Today we're going to talk about something a bit different. We're going to talk today about ethics in machine learning. This is going to be a comparatively non-technical lecture, but it's also going to be perhaps one of the most important in some ways. Often when many people think about machine learning, they just think, okay, it can solve my problems. But I think that's a rather narrow view to think about machine learning, in the sense that you'd perhaps think about the broader influences and what might happen if you use machine learning. It turns out that ML isn't necessarily the answer to all possible problems. There's some cases where perhaps no ML solution would be better, or sometimes there might be negative consequences which are associated with a machine learning based solution. So whenever you're doing some sort of machine learning implementation or deployment, this is an important thing to keep in mind. Think just beyond trying to maximize accuracy, and think what actually is happening here and what are potential downsides of what I'm doing. So I'm going to present today as a number of different just examples of recent ethical dilemmas, issues, just instances which you should think about. I'm going to try to be relatively non-prescriptive, but more descriptive in nature. That is, I'm going to tell you some things that happened, and I'll leave it to you perhaps in some cases to think about. Maybe these are just something that you never thought about before, and you should consider these type of impacts and how you feel about them before proceeding. Well, so the first thing I'm going to talk about is privacy. Now, you might be thinking about privacy as something we've already discussed. Indeed, we already had a lecture about privacy, but beyond there's types of privacy which can be protected by things like differential privacy. For example, the type of privacy which we talked about is things like ML model memorization. What I mean by that is, imagine you have some machine learning model which is running on some data set, some training data set. It's possible actually for that machine learning model to memorize elements of the data set. And if this data set is sensitive, that is, it's some important information which belongs to individuals, then it could potentially leak this important information when you're doing predictions or having it do downstream tasks. So this is an issue, but fortunately this type of issue is solvable via methods that we know. For example, things like differential privacy will allow us to deal with these issues, such as machine learning models leaking data from their training set. So that's good. These are things that can be addressed by DP, or differential privacy. Now, there are some other issues that they somehow have privacy implications, but they're of a rather different nature. And let me try to describe what they are. Sometimes you're wondering, are there things that we shouldn't use machine learning for because it's somehow not the right solution in terms of violating people's privacy? And I'm going to use privacy here in a rather loose way, in a sort of underspecified and casual way. Let me give you some examples. So let me first tell you a story, which is called the Target story, reference to the Target retail chain, because that's how it's often told. Let me note that this is maybe not a real story. It's an apocryphal story, but it's still commonly told, and it's something that you could plausibly see happening. So this is the story, which is that there's a young woman who maybe shops at Target, and she buys things, and she has an account with Target, and it records what she's bought in the past. And after a while, she starts getting advertisements, targeted advertisements to her house. And so her house is sent flyers about different products she might be interested in. And unusually, it turns out that she gets a lot of advertisements related to, say, pregnancy or natal baby related things. And her parents are kind of offended by this because of the fact that she's just a teenager. So why is she being advertised private things for babies? This seems unreasonable. And so they complain to Target, and Target apologizes. But it turns out that the young woman actually was pregnant, and she gives birth to a baby. And sort of what happened here in this probably fake story is the idea that Target it looked at what the young woman bought, and based on these products, which maybe have nothing to do with actually prenatal care or having nothing to do with babies, they actually turned to be correlated with pregnant women, say certain types of cosmetics or medicines. So the sort of point of this story is potentially it's possible, given someone's purchases, to be able to predict certain conditions that they might have, in this case pregnancy. And this is let's just say I'm going to call this sort of a creepy application of machine learning and statistics. I'm yeah, because we kind of feel unsettled by this sort of thing. The fact that Target in this example could be they could infer things about you which you consider to be sensitive information. This, I think, makes a lot of people uncomfortable. Now, let me give you another example, which is also kind of an example of the same phenomenon, but is perhaps not one that you would find as creepy. And this is the smoking causes cancer example. And I think I might have described this in a previous lecture, but let me just sort of say the setup here. Okay, we've done a lot of medical studies that smoking, if one smokes, then they have a higher proclivity of lung cancer. So therefore, suppose you just meet a random person and you find out that they smoke. They either smoke a cigarette or they tell you that they smoke. And based on that, you know that the study exists that says that smoking causes cancer. Therefore, putting two and two together, the fact that they smoke and that smoking often causes cancer, one can put those two facts together and say, okay, it's likely that this person has a higher chance of getting cancer, and yeah, that's your inference about the person. So this is really not quite so different from what Target did in this example, in the sense that they had two different things, two different pieces of information. One is the person's individual shopping habits. Those are just things that a retail store might gather if they have some sort of loyalty program. And they also had the information that if a person buys these items, then it's likely that they're pregnant. So it put those two things together and was able to infer that this person is likely pregnant. So it's really doing the same sort of thing as in this as the smoking causes cancer. It just uses information that one reveals about themselves, however they do that, and combines that with sort of science and the state of the world, in that this is sort of something about what right, it's kind of how the world works in some sense, some underlying scientific phenomenon or social scientific phenomenon. Now, but yeah, you can see that despite these being kind of manifestations of the same type of thing, you can see that this one feels a little bit creepier and a little bit weirder. Okay, let's do one more example that I'll give you, which is also kind of an example of creepy ML, let's call it. And this is an example due to that's a paper by Kosinski, Stillwell, and Rapel. I think this is from a few years ago, maybe 2013. Don't quote me on that. But the idea is this showed that it was essentially looking at Facebook likes. So if you're not too familiar with Facebook, it's a bit of an older platform now. The idea is that users can like various things, and so this was from about a decade ago now. But the idea is, at least at the time, that whatever pages a user likes on Facebook, they were perhaps by default public information. That is, anyone can view it online without having to, either be someone's friend or special permissions being granted. So you'll think whatever you like on Facebook, this is shouted to the world and associated with you. Now, you might think this is fairly innocuous, that if you like a band or something, then whatever, you're happy to declare it publicly. However, it turns out that this actually can leak some information which one might not expect. So let me show you a plot from this paper here. And this is the plot. Let me resize this a bit. Okay, let me put it here. So this is a plot from the paper showing that based on a user's, they sort of asked the following question. Based on a user's Facebook likes, can you predict various traits about them? And this is the sort of probability that you can guess it about them. And you can see that there's very high accuracy for some of them, and all of them are relatively predictable. For example, basically with 93% accuracy, one could predict the gender of a user based solely on their Facebook likes. This might not be super surprising. Maybe, you know, men like men things and women like women things, whatever those are. So maybe it's pretty obvious to tell. And indeed, that's what this backs up, that statistically it is pretty obvious to tell from someone's Facebook likes. But other more subtle ones and more sensitive topics are also predictable. For example, you can see here that someone's homosexuality status is also very predictable from one's Facebook likes, which I think most would agree that, especially a decade ago, this was perhaps more of a sensitive, this was definitely a sensitive topic back then, and it still is today. Other things, for example, whether your parents are together, which you might consider personal information, whether you smoke or take drugs, things like that. These are actually predictable from one's Facebook likes. So this, I think, would perhaps be a little unsettling to people. And just to show you sort of some of the things that are associated with each, for example, this is what some of their findings were in terms of various other things. For example, this is their finding on which likes are most predictive of another trait. They also looked at IQ. That's not on this chart, but yeah, they managed to find which, if you like these things, then they're most predictive of having a high IQ, and if you like these pages, then they're most predictive of having a low IQ. So some of them are kind of natural and believable things, but and maybe very stereotypical things, but some of them are really weird. For example, it turns out that liking the Facebook page of curly fries is kind of correlated with an individual having a high IQ, which is, I don't understand that one. That's pretty random. But yeah, these are some of the sort of likes that were correlated. So that about, well, what else do I want to say about this? This is kind of, yeah, this is kind of a creepy thing that I think one doesn't really consider when, yeah, when one doesn't really necessarily consider this when liking things on Facebook, thinking about whether, say, liking curly fries would reveal that I have a high IQ. I mean, this is not really the most sensitive of topics, perhaps, but nonetheless, you could imagine for other things, you might be inadvertently revealing about your sexuality or your religion or other things which are more sensitive. And again, I claim that this is not really too different from either of these two cases here, except in how creepy it feels, in the sense that, once again, there's a kind of two components which one can put together. One is information that an individual reveals about themselves, which is perhaps what thing they like on Facebook. The other thing, the other thing that's put together is some sort of state of the world or what science says. And the science would say something like individuals who like these things, it's kind of been aggregated over a bunch of people, and you can find out that individuals who like these things are kind of correlated to having a higher IQ. So therefore, you can put those two pieces together and be able to predict features of an individual which may be sensitive. So yeah, this is kind of something to consider, whether this science should even be done, in the sense that what sort of negative things would it lead to, whether there'd be negative impacts of this. For example, if you ran a machine learning algorithm and it somehow revealed the sexuality of everyone in the world via some sort of discovery like this, that'd probably be bad, especially for people who live in countries where this is still highly stigmatized and there are laws against it. Yeah, and one interesting thing is also that this is not future-proof, in the sense that, what do I want to say? Suppose you reveal something, and then later a scientific discovery is made. For example, just to go to the simplest example here, imagine you smoke and you've smoked for years, and then eventually sometime it comes out that smoking causes cancer. Well, it doesn't matter that only now it's known, because even before then you'd revealed that you smoke, so people will still be able to predict your cancer status. So these are not really by revealing public data publicly about yourself, you're susceptible to revelations and scientific discoveries in the future which might violate your privacy in this sense. So yeah, this is the first vignette, and it just kind of says that privacy is a concern, and not everything can be addressed by differential privacy. Some things, if you think about it a bit, these are not really about individual privacy in these cases, in terms of the type of revelation which is happening. So yeah, this is one thing to be cautious and aware of. Another thing to think about is, yeah, let's move on to another topic, which is behaviors enabled by ML. I don't know how else to say it. And by this, I mean some sort of negative societal action, which is enabled by the fact that we have machine learning algorithms. For example, a common one, which many of you I'm sure have heard of, are deepfakes. And these are kind of very popular and an interesting topic right now. And the idea is these are videos, sound, or pictures of someone which show them or depict them doing something which they didn't actually do. And you've probably seen a few of these before. For example, politicians, movie stars, stuff like that. Let me just show you one which has been making the rounds recently, which yeah, kind of shows how effective these things can be. So here's a popular TikTok account by Deep Tom Cruise, and this is not Tom Cruise, but it's a deep fake version of him.
I'm gonna show you some magic. It's the real thing. I mean, it's all the real thing.
And yeah, you can see this is actually like pretty realistic. I think in terms of looks, like it very strongly resembles Tom Cruise, and it's very hard for a regular human to tell whether this is him or whether it's a fake. It's a very relatively good one in the sense that even when he moves his hand over his face, it still doesn't. You still can't really tell anything. So yeah, these are kind of popular. Some are just for fun. Some are for more. This one is just for fun in the sense that nothing really bad has been done with this deep fake version of Tom Cruise, but you could imagine other negative instances of deep fakes, some applications which have been some negative applications of this include things like deep fake porn, that is superimposing someone's face on a non-consenting person's face onto someone else's body. Another application which has the potential for misuse is deep faking of politicians. So for example, the prime minister, somebody could have him make a phony statement, and this could lead to various political actions, stuff like that. So the point I'm getting at here is that deep fakes, these type of imitations, can be negative in terms of causing harm to individuals. Yeah, and there's also some which are, I think, some applications which are rather creepy as well. Let me show you a couple of versions of a couple different things related to impersonating people, which I think are a little bit creepy, I'll mention. So here, this is actually a very recent thing. So there's a movie coming out, or that recently came out maybe, about Anthony Bourdain, who's a very well-known, I guess he was a chef, and yeah, he was a journalist as well, and just a personality who recently passed away a few years ago. And there's this documentary about him. You can see here's a article from the New Yorker. Here's a little bit from it. So the moment at the end of the film's second act when the artist, a friend of Bourdain's, is reading an email aloud that David had sent him. Dude, this is a crazy thing to ask, but I'm curious. this Cho begins reading. But then the voice fades into Bourdain's own, and this is what he said. So this is kind of weird because someone else is reading the email, and then it switches to Bourdain, which is weird because why would a person be reading their own email they sent to another person? And how would they do this after he's been deceased for several years now? And so that's what he asked. I asked Neville how on earth he'd found an audio recording of Bourdain reading his own email. What they found was they got a bunch of different clips of Bourdain's narration because he's been a show host and he's given lots of interviews and stuff like that. And by synthesizing these different quotes together, various voice clips, they managed to imitate this quote from his email. So it says here, he got in touch with a software company, gave it a dozen hours of recordings. I created an AI model of his voice. So I don't know about you, but I personally find this a little bit discomforting, where the man has been deceased for a while now, but nonetheless, without his consent or anything, they still made him say something which he never said. So yeah, that might make you wonder, is this something that maybe we shouldn't do, or maybe it's something that, would you want that done to your voice? There's another one which I think is even more, I find it personally a little bit disturbing. It's kind of hard to watch, and this is on an even more sensitive topic, which is from the Parkland shooting. And you can look up Parkland shooting victim deepfake if you want, but I'll warn that it's a little bit, I find it disturbing. If you don't know, the Parkland shooting was a school shooting from a few years ago in the United States. And the idea of what was done here is that the PSA for gun control, the parents of one of the victims chose to have their son brought back to life by a deepfake algorithm. So it's a video of the victim who's speaking out against gun violence, and I think it's a rather emotional video and very, very serious. It's something which, yeah, I think there are some ethical concerns about using. I personally feel there's some ethical concerns about using a deceased person for such a strong, charged political message, whether you agree with it or not. But yeah, you can use your own judgment here on whether this is something we should consider appropriate or not. Yeah, so this is a new phenomenon which has been enabled by machine learning, and deepfakes are kind of tricky they're generally hard for humans to detect. I'm not sure about the latest on whether machine learning can detect it. I don't think it's, I think we're okay in terms of detecting it, but nonetheless, most people aren't going to be running machine learning algorithms to detect whether a video of Justin Trudeau is actually a video of Justin Trudeau. These things can spread even if we did have things which could detect whether it is or not real. Okay. And another related thing is, another thing which has gotten some press or some concern is fake news generation. So we've talked a bit about GPT and all the different language models in one of the previous lectures. So let me bring up this table which is in the GPT-3 paper. So what we have here is we have the first column here refers to different natural language models. And don't worry about all of these columns over here. These are not a big deal. Just focus on this column. But what this column is they essentially ask some human subjects to judge whether these news articles were real or not. So, sorry, let me say that again. They essentially had this model generate a bunch of news articles, which are fake. And what they did for a human subject is they asked the human subject, okay, here's an article. I want you to predict whether it was generated from GPT-3 or if it was generated by, it's a real news article that was written by a human. And you can see the results here in terms of how good a human is at doing this sort of thing. So you can see for a control, which is a deliberately bad model, this would probably spit out nonsensical articles, things that don't really make a lot of sense. And you can see that humans with pretty high accuracy, with 86% accuracy, can say that, okay, this one's real, this one's fake, stuff like that. But you can see as one considers more and more complex language models that this accuracy of a human prediction goes down, and all the way to the bottom one, where a human can guess with 52% chance whether whether an article generated by the biggest GPT-3 model, whether that's real or not. And just compare this with random guessing, which would be 50-50. So therefore, the sort of conclusion we can draw from this table is that GPT-3, at the largest version of it, the number of parameters, 175 billion, it generates news articles which are roughly indistinguishable from real news articles. And the implication of this is that it could potentially be used to generate fake news articles, which could have significant negative societal impacts. And so this is, I think, a cause that some people have taken this as a cause for concern. And the concern actually starts a bit before this. So this is from GPT-3, but actually the biggest cause for concern was around the time of GPT-2. GPT-2, the paper, or the first announcement of GPT-2, was announced in February 2019. And this is by OpenAI. Let me just call them the organization who has been responsible for the GPT series of language models is OpenAI. And so this was unprecedented levels of performance at many machine learning tasks. People were very excited by this. However, what really, I think, stirred the pot a little bit was they actually claimed at the time that it was too dangerous to release. Maybe not literally those words, so let me leave out the quotes, but it was, they sort of said that, they said that this language model is so exceptionally powerful, they're claiming that it's better than absolutely everything else that's come out before, which is not necessarily true. There are other things that were also very, very good at these tasks, but it's just so good at making this, then if we put this out, then it'll be used for fake news, and it'll ruin the internet and the society we live in. So therefore, we're not going to release GPT-2 for people to use. And this was the kind of machine learning world exploded in the sense that everyone had an opinion on it. If one thing you can say with absolute certainty was that this was a great marketing move, in the sense that everyone was talking about it and everyone knew about it. I personally think it's also a very good thing to think about. Like, at least you should consider whether or not this is true. Is it going to cause a great amount of danger or not? And there were a lot of comparisons people were making, like the arguments nowadays. Everyone talks about fake news, so the arguments about why not to release it are kind of clear, in the sense that it has a potential for societal harm. But the arguments in the other direction were, there were a few different ones. So why should one release it? Some arguments for release. Some of these included things like the fact that the only way to really defend against these things, or how to really understand them, is to release them so that people can play with it, and then we'll know what to expect. So it's kind of like, if you tell someone it exists, then someone, a malicious actor, will be able to discover it anyway. So there's no reason trying to hide it. Let me just say, like, obscurity isn't safety. Another argument is things like, you might think that this is similar to other previous inventions, like the printing press, for example. You could argue that the printing press also enabled, say, massive dissemination of fake news, because now, rather than having to handwrite everything, you can just put it into a printing press and make tons of copies of it, and that would facilitate things. Well, yeah, that doesn't seem to be as big a fear. And similarly, things like Photoshop. Are photoshopped images having a really big problem to our society? And I think the argument which someone said, I'm sorry, I can't remember the name right now, but they said, no, photoshopped images are not a problem in our society because of the fact that everyone knows Photoshop exists. So they're bound to be extra cautious whenever they're seeing a picture which seems too good to be true. So yeah, those are some of the arguments in both directions. And it turned out to be a little bit of a moot point in that there were several replications. So maybe they didn't actually, when they released GPT-2, they didn't actually release the code or anything, but they released the method, right? That's what you describe in their paper that they put out. They just said, here's what we did, here's how you do it, here's roughly the details, and several groups replicated it and were able to do it themselves, say as early as like August 2019. So it was kind of, it didn't really matter whether they released it or not. This was, I think, about half the size of the replication that were put out first, were half the size of the full model, but still pretty sizable and pretty powerful. Eventually, they released all their models. And they released all models sort of towards the end of 2019 when they saw that, okay, it seems like there hasn't been really that much of a negative harm caused by the release of some of these other models, these replications and stuff like that. So maybe it's okay and not big a deal, not that big a deal. So yeah, you might be wondering about GPT-3, which is another story altogether. GPT-3, so the question is, has GPT-3 been released, which is much more powerful? Well, the funny part here is that sometime in maybe 2020, OpenAI, they changed their business model. Before they were, I don't know, I'm going to hesitate to say that they were nonprofit. I'm not sure if they were nonprofit or not, but they essentially transitioned to a for-profit business model, and this is licensed to Microsoft. In the sense that they did not publicly release the code, and only Microsoft can use it for Microsoft products and stuff like that. Other people can maybe pay for API access. But yeah, I think it's a little bit ironic for a company called OpenAI that they've sort of changed their tune so much in terms of going relatively close. Maybe it was inevitable, but yeah, it's very different from the earlier days of OpenAI, where they were more focused on releasing everything as soon as possible because this is the way to progress machine learning as a whole. Yeah, so that's what I want to say about kind of bad behaviors enabled by ML. The next thing is kind of a one-off and just like, let me just call it unexpected behavior. And sometimes it's called, sometimes you can call this like the effects of machine learning in the wild is the common phrase that people use. It's sometimes related to things like robustness, which we've already talked about. But basically, we have these machine learning models, which we train and we run them in very controlled settings, and we try to understand very well what's going to happen under these ideal circumstances. But then when you put them out into the wild and with access to the public, who knows what happens? Things could go totally wild. So I'm going to tell you the story about Tay, which is a chatbot. So this was a chatbot which was released in I guess 2016, I think. And it's a Twitter chatbot in the sense that they post on Twitter and you can reply to the account's tweets, and then Tay will respond, Tay will learn, and things like that. So yeah, basically you can pretend they act like just another Twitter user and they'll have conversations, except the difference is they're not a real person. They're just an artificial intelligence, a machine learning algorithm, whatever you want to call it. Now, the interesting thing here is that it not only communicated with people, but it also would learn from the people it communicates with. So in particular, it was attacked by trolls, people who just wanted to make it say offensive things. So it was taken down 16 hours after launching. And And you might be wondering why it was taken down 16 hours and after 16 hours. And the reason was that users had trained it to be racist, sexist, things like that. In particular, this chatbot, which was supposed to be imitating a 19-year-old American girl, was now denying the Holocaust happened and was saying that they're a fan of genocide. So, yeah, some really horrible things. And so, yeah, I guess the kind of moral of this story, or what happened in this ethical issue, is just being aware of what sort of misuse or what things that you didn't foresee could happen when you release a machine learning algorithm out into the wild. So the next thing I'm going to talk about is on bias of algorithms. So bias has a statistical meaning, say the bias of an estimator, but we're going to talk more about bias in terms of favor of one type of thing in favor of instead of another, maybe potentially favor of one demographic group instead of another, or maybe better performance in one demographic group over another. And this is a very important topic which has gotten a lot of attention in terms of fairness in machine learning. So I'm going to have a few different examples of where this type of bias and maybe where some sort of better, fair algorithms might be needed. I'm going to more talk about the issues rather than potential cures, but there's been a lot of work into trying to see how to really solve these types of problems. So let me show you one example first. And this is from Twitter. This is a cropping algorithm. So you can see someone tweeted here, which will the Twitter algorithm pick, Mitch McConnell or Barack Obama? And you might be thinking, well, what is this? This is just a picture of Mitch McConnell. But if you click on this, you can see what it looks like. So the person posted a picture which looks like this. It's a very long vertical image which had pictures of two individuals, Barack Obama and Mitch McConnell. And somehow Twitter, when choosing which to show here, automatically chose, okay, let's show Mitch McConnell here. You might be thinking, okay, well, look, he's at the top of the image. Okay, it makes sense to take the top of the image. But if you look at this one, it's the other way around. So somehow, whatever algorithm they're using behind the scenes, it's not really clear what they're doing, but the algorithm that they're using behind the scenes, it seemed to always pick the picture of Mitch here rather than Obama. So the hypothesis maybe is just the red tie. It's a preference for red ties. Well, if you switch the tie color, then it still picks Mitch McConnell. And someone suggested, I guess, inverting the colors, which looks kind of creepy, but you can see then it kind of changes things. So Twitter users, as you can see, were rather up in arms. 200,000 people like this, nearly 100,000 retweets, just trying to understand what's really going on here. And some people accused this Twitter algorithm of having some sort of racial bias in the sense that it chooses to show white faces instead of black faces. And somehow these are maybe more interesting. And it's not clear what's going on behind the scenes. It's sort of Twitter's algorithm just automatically picks faces and chooses something to do with it. And the interesting thing is, in the aftermath of this, Twitter engineers, they put out a statement saying that actually they had tested it specifically for this type of thing. They looked for racial bias and stuff like that, whether it would be more favorable to showing white faces versus dark faces, and they claimed they couldn't find anything. But I don't know, it feels like it feels like they didn't really try very hard if it's so easy to do it. But yeah, this kind of shows that the algorithm can have some bias even if it's not really intended to, and even tested against it. Yeah, my personal opinion here is it's not clear why machine learning was actually needed here, or any sort of special algorithm for picking where to show in terms of cropping. For example, it could have just shown the whole image in some sort of, it could have just picked the top, or it could have just shown the whole image in a shrunk format or something like that. But instead, or it could have given the user the opportunity to choose how their photo would be cropped. But instead, it seems like it did something automatically, and I don't really understand, it's not clear to me why that was quite necessary. So in fact, in the mobile version of Twitter, they've actually fixed this by doing one of the things I said, in the sense that it'll always show the full version of the picture and it won't do any sort of automatic cropping. But in the desktop version, it seems like it's not fixed yet, so they just still have this issue. But yeah, this is, I think, a clear case of when bias can creep into an algorithm, even if it's not intended, and in particular, specifically tried to avoid it. So Twitter cropping is one thing to keep in mind. You might think this is a relatively innocuous thing, like, okay, I'm going to put on a bit of a straw man hat, but like, who cares if Twitter cropping is showing pictures of some people and not other people? It doesn't make a big difference. Like, it's just pictures. But this might be a relatively innocuous case where an algorithm kind of goes wrong in an unfortunate sense. But there are other ones which are much more high profile, which have much more significant impacts. So let me bring up, say, facial recognition. And in particular, I'm going to mention the gender shade study by Buolamwini and Gebru. And fortunately, they have a very beautiful website here, so I'm just going to scroll through that and show you what's going on. So the gender shades paper came out a few years ago, and the idea was it was exposing how facial recognition algorithms seem to have disparate impact or disparate accuracy on different racial and gender groups. So let's take a look and see what we're talking about. So what the researchers did was they chose a bunch of faces, pictures of faces, both men and women, and both light-skinned and darker-skinned. And they split up this way. It's going to be, say, roughly half and half men and women, and half, or not half and half, but this is their breakdown into lighter skin versus darker skin people. Yeah, maybe half and half, roughly, light skin and dark skin. And what they did was they compared 3 different companies which have facial recognition software. So these are algorithms which would basically predict whose faces, predict various traits of the face. For example, the individual's gender, or it'll pick up their sex or stuff like that. So you can see, first of all, here are the 3 algorithms that they tested against by Microsoft, Face++, and IBM, and you can see that they're all reasonably accurate, 88 to 94%, pretty good at doing facial recognition. But this isn't the whole story, in the sense that there's many different groups here. For example, if you look at male subjects versus female subjects, you can see that there's quite a significant difference in how accurate it performed on these different groups. For example, the Face++ has the biggest difference, in the sense that it'll have 99% accuracy on males, but 78% accuracy on females, a 20% difference. That's no good. That seems like a pretty big difference. And similarly, if you look at light skin versus dark skin, you can see that, again, there's a significant bias in favor of better accuracy on light skinned. And if you take the sort of intersection of these, or you look at both different things at the same time, whether light-skinned, dark-skinned, male or female, you can see that light-skinned males versus dark-skinned females have an enormous difference in terms of the accuracy in many of these. For example, as big as 34%. So this gets almost perfect accuracy on light-skinned males, but it only gets 2 out of 3 correct in terms of dark-skinned females. These are pretty significant groups, differences in performance based on different groups, and it's something we'd rather avoid. Yeah, I'll talk about the impacts of this type of thing in a sec, but is there anything else that I want to say? Yeah, first of all, that 94% of faces misgendered by Microsoft are those of darker subjects, which is not a good bias. And so it seems like these, it seems like these commercial facial recognition tools are somehow very disparate in terms of their performance between performance on light skin versus dark skin people and men versus women. And so you might be again thinking like maybe this is more serious, but why does this? I still think hopefully this should be self-evident to why this matters to many of you, because it's never nice to be discriminated against based on immutable characteristics of yourself. But this has more serious consequences, especially in very high-stakes situations, such as facial recognition technology, as, for example, used by law enforcement. For example, imagine, there's a picture of you, which is out there on some sort of surveillance camera, and an image recognition algorithm picks you up and say, oh, you're a criminal of some sort who's wanted. And so based on this facial recognition technology, they take you in and question you and maybe even convict you using this type of facial recognition evidence. So let me just point out that this is big consequences in justice system. So this is something, a kind of a very, very high stakes application of these facial recognition technologies, which are really, they seem to have some serious deficiencies, even though they have good accuracy overall. So it might seem, okay, these are ready to use. They have 90% plus accuracy. It turns out if you look at a little bit deeper, then there's some negative consequences that will happen if you're not careful with them. And these sort of findings, as well as other things, have caused many companies to rethink their uses of facial recognition technologies. For example, IBM, they just stopped doing facial recognition. Companies like Amazon, they put a pause on their, they have an image facial recognition service, but they have put a multi-year pause on their usage with law enforcement. So kind of with concern for things like this. And similarly, also Microsoft, they have facial recognition technologies, but they again have said that they're not going to sell to law enforcement for the time being until perhaps that there's laws in place which govern and regulate the use of this type of technology. And yeah, besides just these types of, even beyond just the type of bias involved with facial recognition in terms of treating different subgroups, let's pretend facial recognition was completely perfect. That is, for each individual, every individual, it could exactly tell you with 100% accuracy whether there's a picture of the person or not a picture of the person. And the question is, in these cases, if it never made a mistake, is this okay? Should a law enforcement agency be using this type of facial recognition? And I think a lot of privacy advocates, myself included, would probably say, no, this is maybe too much of a privacy violation for individuals. That we shouldn't be using algorithms for these sorts of things because this just is, it's not really necessary, I'd say. And it's a dangerous step to go on in terms of personal liberties. So that's another application, which sort of you can see there's some, but yeah, going back to the sort of point of this little segment, there's some serious bias which creeps in, which unfairly affects certain demographic groups when you look at facial recognition technologies. Another thing I'll mention is hiring tools, which is, I think, it's not exactly just bias, but it's also the question of should we be using machine learning to do these types of things. So what are hiring tools which use ML? Well, there's a few different things. For example, auto resume screening. So for example, you can imagine that a company is trying to recruit, so everyone submits their resumes, and it takes a lot of time to look through all these resumes and read them. So what can they do to just get by all of this? Well, they can say feed them all into a machine learning algorithm and try to predict which ones are going to be good employees or not. and just maybe using this as a first round screening. You're not literally hiring everyone who passes this resume screen, but at least identifying the ones who look the best in terms of which are the best candidates. Now, Amazon, for example, did this for some time, but in 2018 they decided to stop doing this because they found that their algorithm was unfairly penalizing people for putting certain keywords in which were associated with gender or race. They kind of did some testing to find out, and they found that this was hurting certain applicants unfairly. So they stopped doing it, even though they found a way to fix that type of unfairness. They couldn't be sure that there were biases present in the algorithm which which they couldn't detect. And that's an important thing to keep in mind. Even if you think you made your algorithm fair, there might be some certain dimensions upon which you can divide your data, and it still nonetheless enforces or propagates some sort of bias. So you have to be very, very careful. It's not easy to just say, oh, it wasn't sexist, so therefore it's all fine, because it could also be racist in some other way. And I'm using these in a casual sense. Of course, like an algorithm itself is not going to be outwardly racist in terms of its behavior. It's an algorithm, it's some code. It can't actually have these sort of personal traits, but it could be discriminating in terms of the decisions that it makes in ways that we wouldn't want. So this automated resume screening is one sort of instance which machine learning comes in, but it's very easy to introduce bias there. And another thing is interview video analysis. And this is this is growing surprisingly fast in terms of an industry, where essentially you do an interview video and then you submit to a company, and they'll have some algorithm run on it and be able to predict whether, okay, you made it past this first screen, and whether we should look more at your candidacy. And yeah, the kind of weird thing about this is this video analysis doesn't even necessarily use your answers. Like, you might think, okay, maybe it's not so bad if a video if this tool will record what you say and maybe convert to text, and based on the answers you gave, like, okay, you answered a technical question correctly, so you proceed, or you didn't. But what I find a little bit unsettling about these is it does some sort of prediction based on things that are, say, nonverbal cues. For example, your facial expressions during an interview, your eye movements, your body movements, things like your clothing, what your voice is like at various points. So these are perhaps things that humans wouldn't even notice, but nonetheless it's making decisions based on them, and we don't really understand how it's making decisions based on them. Other things like perhaps word choice and something like that. But the point is that these decisions that it makes about who to give a good score versus not a good score, these are based on mannerisms rather than the content of what you're actually saying. And I personally feel like trying to do some sort of predictions based on these nonverbal cues and stuff like that is a form of pseudoscience. I don't think these types of things actually have that much predictive power, even with a perfect type of predictor, in the sense that yeah, it seems weird that if you can look at someone's eye movements and be able to predict whether they're going to do well at this job or not, that seems like something that really shouldn't have that much predictive power here. So yeah, nonetheless, it's still gaining a lot of popularity because it can save a lot of time for interview screeners, so that they don't have to interview every single person, and they can save their time doing something else. Somehow, the companies who do this sort of thing, they claim that it removes some of the bias from the loop. And the reason they claim that is because they make the assertion that humans have various biases, so by not having a human, we can have an algorithm do things better than the human would. Now, that may be plausibly true on some dimensions of bias, but the thing is, the problem is that it's very likely that you're going to introduce biases in other features and in ways that you can't even maybe control for, whereas maybe you could tell a human to be aware of these sorts of things and have better better control over these types of biases that manifest. And beyond that, I guess like there's a more philosophical question. We'll talk about this a bit later, but do you really feel comfortable about an algorithm making such high stakes decisions on individuals? Or do you think this really should be a job that a human does? Okay, so that's it for hiring tools. Let's talk about one last instance where bias comes in machine learning algorithms, and this is what is known as Compass. So Compass is an algorithm, and it is in particular a risk prediction assessment. So what do I mean by a risk prediction assessment? Well, consider the following situation. Suppose that you're arrested for whatever reason, and there needs to be some sort of sentencing decision for whatever crime you committed. And okay, so the idea is if you're perhaps very likely to offend in the future, that is, you're a dangerous criminal and you're going to do bad things again, then perhaps you should have a longer sentencing and you should be kept in jail for longer. But if it seems very unlikely that you'd commit crimes again, maybe it's okay to say that, okay, you're not going to be that big a deal. Let's give you a small penalty and let you go. So if you could do this perfectly, you can see that this might have some sort of great value to our society in the sense that if you could, for each individual person, predict with perfect accuracy whether they're going to commit crimes again or not, that would be amazing because we'd be able to make decisions based on that very effectively. However, this is that's a very big if you could do that because it's probably not possible. But nonetheless, this Compass algorithm is something that is used by many states in the United States to try to predict the sorts of things. So the idea is the following. An individual's history is fed into this algorithm. So there's 137 different features in this algorithm. And based on all sorts of things like various information about an individual, as well as the individual's criminal history. For example, how many crimes they've committed, what sorts of things they've done in the past, what their level of education is, and all sorts of things like that. And it gives an individual a score from 1 to 10. And the idea is that if you have a low score, a 1, that means you're very unlikely to be committing another crime in the future. And if you have a 10, then you're a very high likelihood of committing a crime in the future. So the idea is perhaps there's certain rules about when judges are and aren't allowed to use this information for what sort of task, but sort of intuitively, the thing that kind of ends up happening sometimes is that people with a low score, with a score like 1, then they'll be given lighter sentences, and people with a higher score are given more severe sentences, or maybe won't be eligible for parole as quickly and stuff like that. So yeah, this is something which is a very, very high stakes type of application because there is often, in many cases, a big discrepancy between the minimum and maximum sentences for a crime. So the question is it any good, and are there issues with this? And I'm going to show you there was a ProPublica, an organization known as ProPublica, which did some analysis on this. So let me just move this. Sorry, let me put this on the next page. Which did some analysis on some data. So the interesting thing about this is this data isn't generally available. You can't just get it freely from downloading it from a website. But what is kind of cool is you can do a Freedom of Information Act request, which essentially various data which is done by public institutions in the United States and Canada, you can just say, hey, I request this data, and they have to prepare that data and give it to you. And in particular, they could find a lot of information, which is, I consider somewhat sensitive or important. The very important data set, which can allow you to look at what really happened with this data. What sort of scores did individuals get? And did they commit crimes again in the future? So here is some of the data from their analysis that I took from their notebook, which they have on the internet. And this just focuses on a certain subgroup, the Black defendants. And this says their various statistics here. So let's interpret this data. So on this axis, you see that there are two types of individuals. Those who, okay, the terms are a bit weird, but survived means didn't commit a crime. Like in the future, they didn't commit a crime. Whereas recidivated means that they did commit a crime in the future. And here we have that their whatever their score was, their their score in terms of whether they're high or low risk in terms of what Compass predicts. And yeah, what you can kind of what you see here is that there's two statistics, one of which is the false positive rate. And essentially what the false positive rate does is it looks how many false positives, what fraction of the true negatives were actually, or sorry, what fraction of the negatives were predicted by the algorithm to have a high risk. So yeah, you can see that this is a rather high number, almost 50%. So where did this number come from? Let me just show you where this comes from. This is this 805 here. And that's divided by 805 plus 990. That is the false positive rate, which looks at the number of people who were predicted to have a high risk but didn't actually commit a crime, and the divided by the total number of people who didn't commit a crime. That's what's known as the false positive rate. Similarly, we have the false negative rate, which is if you look at all the people who you take the number of people who didn't commit a crime, or sorry, who had a low score but did commit a crime, and then you divide by the total number of people who committed a crime. 532 divided by 532 plus 1369, and this is something like 28%. And that's where we get the other number here. So, okay, these are the two rates which you have for black defendants. So, I don't know. You might be wondering, are these good? Are these bad? Ideally, like we'd ideally like to have 0 for both of these. That is, all individuals should fall here and or here, because this kind of means that we made a mistake. We said someone is a big risk when they didn't actually commit a crime, and here it would be that they did commit a crime, but we predicted that they wouldn't. So these are both mistakes of various sorts. And so those are numbers, but how do you interpret them? Are they good? Are they bad? Well, they should be low, but these are unfortunately a bit high, I think. But you can see for white defendants how these numbers differ. So don't worry about the calculations here, but like just take a look and see that the false positive rate for black defendants is much higher, and these are the type of errors which would be working against the individual. For example, this means the false positive means that you're predicted to be a big danger, but you weren't actually. And so you can see that it somehow leans in favor almost twice as much of saying that black defendants are going to be dangerous when they aren't, than compared to white defendants. And on the other hand, when you have a false negative, that is kind of in the individual's favor again. In this time, it's in the individual's favor. It means that you got to get out of jail even though you were actually a threat and you committed a crime. And you can see that this number is much higher for white defendants. And actually, I think both of these are like pretty dramatic in the sense that pretty much 50-50 when it comes to people who actually did commit crimes for white defendants. It's a coin flip. It didn't really manage to get any significant predictive power. Similarly, when saying for black defendants who didn't commit a crime, then you can see it's also again maybe 50-50. So the algorithm is really quite poor in some cases, and you can see it's also in terms of when it doesn't work well, it's to the detriment of black defendants much more than white defendants. So we can see a significant bias with high with high consequences for individuals involved. So this type of data set is now a test bed for trying to come up with algorithms which try to avoid these problems and come up with something which is maybe a little bit more fair and doesn't exhibit the same bias. Yeah, I'll point out that the algorithm itself is actually not very accurate for certain cases. For example, there's also a finding that only 20% of the people predicted to commit violent crimes actually did. So even bias issues aside, it can still be pretty inaccurate at some points. Yeah, so it's maybe not that good an algorithm. Okay, and I'm just going to wrap it up with some very, very speculative things here. Like this is sort of a more philosophical questions. And these are things like totally outside my area of expertise, but these are just things that I want to mention to you because I think they're kind of fun and interesting to think about. So really, these are things you can definitely make your own decisions about what you can or can't do here. So let me bring up a common picture which you might have seen many times. So this picture is used in many memes. This is the trolley problem. And this might not seem to have anything to do with machine learning or anything, but let me ask, this is the idea is the following question. So there's some trolley, so this is you right here, and there is some trolley which is out of control and it's just going down the tracks, and there's it's currently en route to go and hit several people who are on the tracks. So it'll cause a lot of injury and potentially death on the way it's headed. So, but you as this operator here, you can pull the lever, which would instead divert it, and it would only hurt one person now. And so the question is whether you as the individual, should you pull the lever or not? And you could think that this is sort of like a very common philosophical discussion. A lot of people talk about it. The idea is that one obvious answer would be that you should pull the lever for sure because fewer people will be injured. But on the other hand, other people would say, but if you pull the lever, you're doing harm to this individual, whereas by just leaving it, you're allowing harm to happen. And some people consider these to be qualitatively different. I don't think there's really a correct answer to this. People differ in what they think what the best thing to do is. But the thing is, this is something would be kind of understanding of a human having to make these types of difficult decisions and understand kind of whatever they do. This is kind of, it's a no-win situation. Now, okay, but this is for a human making this type of decision. The question is, what if an AI or a machine learning algorithm has to make the same decision? So the trolley problem, as it's called. So the question here is, for example, imagine you had a self-driving car. Would you be okay with a self-driving car making these types of decisions? So this is maybe speculative. We don't have self-driving cars yet. They're still in the works. But say, 100 years from now, maybe when we have perfect self-driving cars, which can drive perfectly. And let's just say that a self-driving car had to make a kind of similar decision. It's going to hit some people if it keeps going, but otherwise it could swerve off the road and hurt some other people. It's not quite exactly the same type of thing, but the point is that it might have to do kind of similar high stakes ethical decisions. Now, the question is, are you okay with an AI doing this type of decision? Yeah, somehow it's kind of different when you have an AI do it than a human do it. So who would make the decision? Would the person writing the algorithm, would that person determine which is the morally correct act or not? And why should they have that type of power? So this is just an interesting question to think about. Are we okay with AIs and algorithms making these very high stakes moral, ethical decisions? And if not, who? Where does the responsibility lie? Another thing that I'll mention is here's a sort of interesting hypothetical. So suppose you're given two options for a doctor. One doctor is a real doctor, a human doctor. which has 90% accuracy, whatever accuracy means here. Maybe this is for diagnosis of various diseases. They can tell you why they made a diagnosis. For example, they can tell you why they said this person has cancer. They can give an explanation of it. They had this symptom, and this is what we did, and so we find out that they have this type of thing. That's one choice. They're pretty good accuracy. But now let's say that the other option is an AI with 95% accuracy. But it's a black box. By that, I mean a black box. It just makes a decision, and it doesn't really explain to you why it made that decision. It just says, this is the answer, trust me on it. It's more accurate than the doctor, but it's kind of less interpretable, or it's less clear on what it's doing. Which would one pick, and which should one pick? You might think that, okay, maybe 95%, it's obvious that we'd pick the more accurate one. That's the one we should use. But it's kind of unclear how it's working and why it does or doesn't work. I think some people would find this more uncomfortable, especially because maybe we don't know where that 95% accuracy comes from. Perhaps if you're a uniformly random person of the population, maybe this is great. But maybe it doesn't work very well. That 5% error is all on, say, University of Waterloo students for whatever reason. That's not that. Then you wouldn't want to take this type of algorithm, this AI algorithm. On the other hand, yeah, doctors can also suffer from similar biases, and in fact, studies have shown that they are often less accurate on certain demographics. But somehow, people might be okay with a doctor making these types of mistakes compared to an AI, because one, we kind of understand, and one, we don't as well. So yeah, again, I don't think there's really necessarily a right answer here. It's just, I think it brings up the same interesting question about what do we trust an AI to do versus what do we really think a human should or shouldn't be doing. Yeah, and the very final one is probably the most wacky, which I'll get at, is, just to conclude, is artificial intelligence intelligent? Like I said, take this with the heaviest grain of salt, because this is just something that's kind of fun to think about from a more philosophical sense, not really something we probably have to worry about right now. So many of you have probably heard about, let me use a different example first. Like, let me show you an illustration. I found this from Wikipedia of what is known as the Chinese room experiment. So this is an illustration of what the Chinese room experiment is. The idea is that someone on this side, they feed in some sort of message into this room, which is some Chinese character. Then the person inside, they have this big book of all possible messages in Chinese that they could receive. And then based on the message they receive, they're told this is the right response to give. And so they look up in their book, what is the right response to give? And they put it in this out box here. So the idea is, in some sense, you could picture this person who's on the inside as being able to have a perfect conversation with the person on the outside in Chinese, even if this person doesn't know Chinese themselves for whatever that actually means to know it. So the question is, the kind of philosophical question is, does this person know Chinese if they're able to come up with a response to every possible message that they could receive with an appropriate response? Yeah, it's kind of being able to give the right answer somehow different from internally understanding what you're doing and what you're saying. A related question, which maybe you have heard of, this is a little bit more obscure, but it's still popular, but another thing which I'm sure many of you heard of is the Turing test. And this is kind of asking, this was asked by Alan Turing way back in the day, for the very same reason, asking, can a computer be intelligent? And so he proposed a type of imitation game where essentially a computer would try to do things that a human would do, and see if a human observer could predict which one it is, whether it's a computer or a real human. And the idea is if a computer is indistinguishable from a human at whatever task, then it passes the Turing test. And he uses Turing sort of proposes as some sort of proxy for what it means for a computer to be intelligent. Now, you might be thinking this is a bit silly because maybe there's some really good chatbots which you talk with, and okay, you can't really tell whether or not it's actually really a person or not. Okay, that's fine. But let's suppose that's just a Turing test. Imagine a more advanced Turing test where instead of just being a simple chatbot, it was more complex than that. You can somehow have more experience with it. Maybe it's like a robot who's very human-like. You can have a conversation with them, and you can't really tell the difference between them and another human in any single way. They're absolutely indistinguishable. For example, it seems like they have emotions. And in terms of any real human, if you put a human into that situation and they would react similarly, it seems from the outside that they can feel love, that they can feel sad, that they can feel happy, and all these sorts of things. So let's suppose you had a totally indistinguishable AI from a human in every possible way. Now the question is this AI? Is this a conscious AI? Has it become conscious? Is it intelligent? And this is a very sort of important and deep question, because suppose this is actually a real, conscious, intelligent object. But we use AIs to do our bidding all the time. In some sense, this might sound silly to you, but we use AI algorithms, machine learning algorithms, as very simple slaves, which again may seem absurd for things like running logistic regression. Is logistic regression a slave? Well, it's not even. It's just a few lines of code. It's not really too big a deal. But you could imagine there might be some serious ethical considerations. This is like maybe not anytime soon, hundreds or thousands of years now. But if we had a truly indistinguishable AI from a human, are they alive? Are they conscious? Are they intelligent? And perhaps most importantly, are they worthy of moral consideration? Should we treat them as our equals? Or are we okay with enslaving them? These are, I think this is, like I said, this is a little bit out there, but I think it's an interesting question to sort of think about in terms of very speculative AI ethics. And a lot of people spend a lot of time thinking about these types of questions as well. So, okay, yeah, that's it for ethics. We went from very concrete and specific things that you should watch out for to the very speculative. But I hope this, at least, if you got anything out of this lecture, I just really want you to think about what the implications of your work are beyond just running an algorithm and seeing what happens, because really things can have much more impact than sometimes you can imagine.